Now we need to remember that we can also use the rules of angles in a triangle and angles in a quadrilateral to solve questions where we have to make equations and find missing angles. So we know that angles in a triangle sum to 180 and angles in a quadrilateral sum to 360. That's because all quadrilaterals, no matter how you draw them, four-sided shapes, that's very badly drawn, but you can see you can always split them up into two triangles. So it's 180 plus 180, which gives you 360. The proof for triangles is in another video, but you can see that we can also use these rules. So here are two examples of questions where you're going to need to just know that rule. So it won't tell you to use this rule, but you're expected to just know it. So in this case here, to work out the missing angle x for this triangle, we know that if it says give reasons for this answer, you would literally just write this out, as you can see there. So in this case, we know 30 plus 100 plus x equals 180. Collect the like terms together, so it's 130 plus x equals 180. And then take away 130, take away 130. So x equals 50 degrees. And then this one here, so we are going to just check, there's a quadrilateral, you can see these two angles are 90 degrees implied by the diagram, and we know that 90 plus 90 plus 135 plus y must equal 360. So 90 and 90 is 180, and then 180 plus 135 is 315, plus y equals 360, and then we're going to take away 315 from both sides. So y is equal to 360, take away 315, 45 degrees. And that is it for that. Okay, let's look at some more examples. So pause the video and have a go with this. This one's a quick one. Okay, so you will have spotted here that you've got a transversal here, and then you've got a pair of parallel lines. So these are, so y and 113 are, they're not corresponding, but they're alternate angles. So they're equal, so you can say y is equal to 113 degrees. Okay, next question. Pause the video and have a go with this. This is a quick one as well. So you should be able to spot that these are also alternate angles. So z equals 98 degrees because they are alternate angles. Okay, next one. Pause the video and have a go with this. So you may have spotted here that they are in the same position on the same side of each transversal. So we can say they are corresponding angles. So y equals 96 degrees corresponding. Okay, next one. Pause the video and have a go with this. Okay, so we can see that they're in between the parallel sides on the same side of the transversal. So y plus 123 degrees must equal 180 degrees because they are co-interior angles. And then here we can just solve this equation. So we're going to take away 123 from both sides. So we can say y is equal to 180 take away 123, which is 57 degrees. Okay, next question. Pause the video and have a go with this. Now we need to make sure we're careful. There's lots of ways to do this. I'm going to take one particular approach. There's lots of different ways to do this. I can't possibly do all the ways. I mean, I can, but I'm not going to. I am going to say that this angle here, I'm going to work with this angle first. I'm going to say that angle is 50 degrees because it's corresponding. Now, normally diagrams like this will have letters on the end of each of the lines or for the angles, so you can actually reference them when you're writing the answer on the side. But here I'm just going to use the diagram as the example here. And then we can say from here, 50 plus y must equal 180 degrees. And the reason for that is angles on a line at a point, and we can get away without saying at a point, but here we say angles on a line at a point sum to 180 degrees. So if we take away 50 from both sides, we can see y is equal to 130 degrees. And then we've got the x that we need to work out. So we can say x is equal to y because they are vertically opposite angles. So opposite, sorry about my handwriting here, angles. And because they're equal, then we can just say x is equal to 130. Handwriting is terrible on this, but you can get the idea. So there's a lot of marks to be had here. First mark maybe for stating that, second mark for making the equation and then solving it and putting the statement, and then this statement that they're vertically opposite, and then the actual angle as well. Okay. Have a go with this one here, give reasons for your answer, and then I'm going to go through it with you. Okay, pause if you need more time. The first thing you notice is x is equal to 64 degrees. You don't need to show any working out because they are vertically opposite. Angles. So we can label that 64 degrees, and then we can see z and 64 degrees are corresponding. Angles. So that's going to be 64 because they are in the same position, on the same side of the transversal on each bit of the parallel lines, and then 64 plus y must equal 180 because angles on a line sum to 180. So we're going to take away 64 from both sides. So y is equal to 180 minus 64, which is 116 degrees. So notice something about these questions. There's lots of reasons to be given for these answers. So the angle, the reason, the angle, the reason, the angle, the reason. Easily 6 marks there for doing not too tricky maths. So here is another example. Sketch this shape out and see if you can work out all of the angles you can, and then I'm going to go through some potential ways to do this. Okay, so let's start with labeling angle AEB. So if you trace your finger along from A to E to B, then this is the angle that we're interested in. That's AEB. So we're just going to mark that. And then it says work out all the angles you can with reasons given. So this time around, I'm going to stick to using the diagram to label the angles here. So first thing we can say is, just if you look at a rough sketch, you can know that these are parallel lines because they've been labeled like that. So this is a transversal and this is a transversal. If we extend these, doesn't really make much of a difference, but we should know, for example, that these two angles must be corresponding. We can say, for example, these two angles are alternate angles, they must be equal. These are alternate angles. There's lots and lots of other things here. We know that, for example, these three angles will add up to 180 because it's a triangle. We know, for example, that these four angles here add up to 360 because it's a quadrilateral. And there's lots of other stuff here as well. So we're going to keep it simple. Try to work out all the angles from what we've started with. So what I can say is this 63-degree angle corresponds with that. So we're going to label that 63. I'm going to just change my pen so you can read it. So that's going to be 63. So corresponding with, and this time we've got letters on the diagram. So this is the angle it corresponds with, which is EDC or CDE. So corresponds with EDC. So equal. So it's equal. And then if we know that 63, we can also work out this angle here because it's angles on a straight line at a point. So this angle here, or the other thing we could also say is that these are co-interior angles. So 63 plus this angle here will be 180. There's lots of different ways, like I said. So we can say this is DEB. So 180 minus 63, which is 117 degrees. Because angles on a line sum to 180. We could have used many other reasons as well. So that's going to be 117. And then we've got this quadrilateral here. It's a four-sided shape. So we know that all the angles in this quadrilateral have to add up to 180. So let's work this one out here. So this angle is going to be 360. Take away the other three angles that we know. So take away 117 plus 148 plus 63. We'll add it up. So that will give you 360 minus all of that, which is going to give you 32 degrees. So that's 32. Now we also know that this angle, this 32-degree angle, is also equal to this. And that makes sense because they are corresponding. So we can say, well, we need to give a reason for this what we've just done here. So we need to write angles in a quadrilateral sum to 180. So sorry, sum to 360 degrees. And then we're going to look at this one up here. this is going to equal 32 degrees because it's corresponding with the 32-degree angle at the bottom, which is BCD. So angle BCD. You could also draw the little hat on top of the C if you wanted to. And then from there, we can label that, and then we can work out this top angle here. And this is based on the idea that this is just a triangle, and we know that's going to sum to 180. So let's work this out. So it's going to be 180 minus brackets 63 plus 32. That's 85 degrees. And we can say angles in a triangle sum to 180 degrees. And that should be enough. 85, that should say. That should be enough for this diagram. So you can see there's loads of different reasons we can give for these types of questions. I'm going to show you some more examples in the next video.